requesting Dr. Mary Sujata ma'am to give a brief note about today's keynote speaker, Kalidas. Thank you.
Good afternoon, sir. Good afternoon, audience. Today's speaker, Kalidas Yeturu sir, is from IIT Tirupati, who is working as Associate Professor in Department of Computer Science and Engineering. Kalidas sir has done his PhD in the Department of Center for Data Science in Indian Institute of Science, Bangalore. He received Sir Vital N. Chandrawar Memorial Award for his best thesis in 2011. He has many research papers who are cited around more than 500 citations are there for each paper. And his profound work is being has been received many patents, around 6 USA patents, more than 6 USA patents have been received with 10 more citations. This is a brief introduction about Kalidas sir, who is really worth enough to have in this session. We are very glad to have you, sir. Welcome.
Thank you very much. Respected people on the dais and off the dais, I will start with my session now. So in this session, let me just switch off my phone so that it doesn't record. Airplane. So in this talk, I have selected 2 topics for presentation. One is related to Indian knowledge systems, one project I did on inscription images. Can we get information from archaeological sites? That is one project what I worked on. So the second one I wanted to present is related to our efforts on digitization of ancient documents. So what are the tools and algorithms we have developed in that regard? So these 2 topics I will present in this 1 hour session. So this was the work that happened 2 years back. We are waiting for the funding from the SHRI still to continue further. So we have developed one algorithm or one platform called Shri Akshara Annotation Systems, where the input to this platform is either the palm leaves or ancient manuscripts written in different formats. It can be either copper plates as well. So the user will be provided with an interface to annotate certain items, and the models will be trained on the fly in real time. For example, if we take object detection problem, so the machine learning algorithm typically will be trained on the server in an offline fashion. For example, let us say a Google Lens. Okay, so I will also tell how Google Lens output can be used. So Google Lens is detecting some objects, let us say. Now, one of the objects it has not recognized, or we want to correct the output of that detection. So it gave some output, but you are not happy with the output. You want to add something that missed out, or you want to modify something that it has not correctly predicted, let us say. Now, can you train Google Lens in real time with your correction? It is a very hard thing to do because the model is very large. Is there a smarter way where we can augment these outputs? You get the outputs, can you modify it in real time? The answer to that question is there are a couple of ways to do that. One way is to have a correction model, or the second way is to have a very lightweight model that allows user to verify the outputs and correct the outputs on the fly. So in this platform, what I'm going to show is a couple of examples on that front. So as you know, so this is a precursor, like some people who are already familiar with this domain, they know it, but just for those who are new to this object search problem, what am I saying object search? For example, if this is an image of a bill, some bill it is there. Now I want to search for some text inside the bill. You see, this is a GIF file I'm playing. So when you search for a word in an image, you will not be able to find that word in the image because it is not having text layer on top of it. So in order to search an image, you have to add a text layer to that. That means at this coordinate, this is the text. At this coordinate, this is the text. So to add the text layer, there are a number of existing tools. So if you look at OCR engine, that's called optical character recognition. There are several OCR engines that are available. So some of the requirements of these OCR engines is formatting of the input itself. For example, if we give a text photograph of a text document, it requires all the characters to be either in a particular line format, or it requires, sorry? All right, this good. So, okay. So it requires the input to be having certain structure. What is the structure? You want all the lines to be separable. There should be lines of text such that you can cut one line, you can cut another line, you can cut another line, and so on. So how you cut them? You apply heuristics there. Or all the characters to be separable. That means, for example, if you have A, B, C, D, you want A to be not touching B, or even if it touches B, the touch should be less. And U means the algorithm typically wants everything to be identifiable as an island. So this is called island detection problem. So there is one library called OpenCV. There are some function calls such as find contours function is there. So that will give you islands in that. You can specify some parameters to that saying this is the density I want. So there is one algorithm also called dbScan algorithm, density based clustering algorithm. So where you specify two parameters, one parameter is called radius, the other parameter is called number of points in the radius you want. So radius is r, number of points within that radius to be expected is n. If you specify them, you get one set of islands. If you say that I want more points in my neighborhood, you'll get very thick points. If at all density of the points is very high, you get very thick dots as islands there. So this may not be applicable when text is handwritten text, because handwritten text looks like this. Let me show an example of handwritten text. Can you see the visualization here? So though I am talking about palm leaves, I am showing a medical record because algorithms are same. Whether you design algorithm for palm leaves, the same algorithms works for medical records. I have a government project here, core research grant here. So I'm showing this type of data for complexity case. So if text is of this format, what OCR can we do on this? See that? Very tough, right? So a medical record, typically people think of it as a prescription, but this is not a prescription. Is it a prescription? No. It's somebody's inpatient record. So how do we recognize text in that? Okay, it's very hard to do OCR on that. If somebody wants to do OCR on that, that's going to be very tough, because optical character recognition, there is no character here. People just wrote like this, but you can find that the handwriting patterns of one person, one doctor or one nurse, is uniform across the entire documents. When they write like this, paracetamol for that doctor, when they repeat that, it's paracetamol for that same doctor again. Only thing is the size may change, or slight natural variations, Gaussian variations may be there in that. So this is the nature of data we are targeting. See that? Light variations are there. So it has strong relation with palm leaves also. So palm leaf images, I will show the images. I will go back to this presentation and show the palm leaves now. So palm leaves are no different from these handwritten prescriptions you are seeing there. They are subject to damages. Natural damages will be there. Some places characters won't be visible. And when the writer changes, the handwriting style changes, and there will be so much cluttering of the handwriting. I do have the palm leaf images. I can go to the directory and show you. Let the flow happen in this way I was saying. So basically the problem is, can we add text layer to an image? That is the fundamental problem. The answer to that is yes, there are multiple ways. Let us look at a couple of ways in that. So what do we do if we are able to search? Okay. So the answer is, what is the use, right? If you are able to do OCR for palm leaf, the application is you can create very engaging interfaces. For example, if one goes to Wikipedia, they find one hyperlink, they click that, they go to another hyperlink, they click that. It engages the user. So can we engage the user in Indian knowledge? The question is, if the users are provided some systems where it is engaging experience for them such that they cling on to it, that will be good for us. So one of the ways in which to engage is to provide a number of search options. It can be voice, convert to text and show the original content there, or it can be text, or it can be a part of the image as well. Like you just say, just drag drop, take this much and put here and search. It should be able to search. So how do we accommodate that in the form of algorithms is the problem statement here. So these are all various problem statements out of which we try to address only one problem statement now. We're waiting for the funding to address the other problem statements. So this kind of references, right? You see the red color references. That's called attribution. For example, in large language models, it gives an output or it makes some statement. When you ask, what is the source of your statement? And the large language model is able to refer to say, because of these things in the literature, I am making this statement. So that is called attribution. So attribution is the most desired behavior required in large language models. That also called explainable AI. So attribution is one thing that we need for knowledge systems, as well as we need some summarization tool. So initially, it was difficult problem, like how do you summarize unstructured pieces of text? If I just throw on this bench some pieces of text, can I summarize that? Till 2017, it was a difficult thing. You have to engineer your own algorithms to stitch them up. But now it is very easy. You just throw the set of words and the LLMs are able to nicely structure it. So structuring of the text is much easier problem now. So these are all the things that are possible once we have the knowledge source accessible in that format. So the state of the art here. So just to show the complexities, it looks like this. Sometimes the photographs itself may have capturing issues, but that will not be a problem if it is captured in a professional atmosphere. For example, if Kanchi University is photographing, these problems won't come. You always get very high resolution images. But there will be problems like, you see this hole here? That hole was a punch hole there in the document. There may be holes by the termites itself. They may eat it and then damage the document. It looks as if bookworm, right? As if the worm is reading the book. So the bookworm pattern looks like letters. So such kind of problems also come. So how do we know what is a genuine letter? Letter written by a human or letter written by an insect, how do we know that? So these kind of problem statements come in these document sources. So again, it has gone. So the complexities are, as you are seeing on the screen, lot of variations. And one more interesting thing is, you see the lines here, right? Okay. This is, is playing with me. Yeah, I will not touch it. So these lines also need not be horizontal. So in the palm leaves, when they photograph, yeah. No, when I am going there, it is changing. It is sensing it. Huh? Yeah, I just left it there. I want to use this only. So the lines in the palm leaves, they may have curvy patterns because the way it is written and the way it is photographed as well. So can we detect those lines which are curvy? Is an interesting problem. Sometimes they also do artwork. For example, Sri Rama, they will write in the, like the Dhanus of Sri Rama, they write Sri Rama, Sri Rama, Sri Rama like that. Can you detect that? So the word patterns itself, there is word art. So how do we detect all those kind of things are interesting problems, peculiar to these types of document sources. Okay, there are existing works in Indian system also. IIT Kharagpur provides a library, digital. So we have gone there and tried to download a few items and all. IIT Kharagpur provides digital library. It has several thousands of documents. That's what I have seen. So they also have these PDF sources. But one problem there was they were not yet OCR'd. I would say text layers were not yet added. They digitized and safely kept it. Text layers were not yet added. So that is one opportunity area to contribute to their initiative as well. So there is one thing called E-Aksharyan. So E-Aksharyan is also there, but how do we add some corrections to that? Let us say you have to live with what it gives. So is there a way you can correct it and augment and improve the model? So those kind of features are not yet available in E-Aksharyan. E-Aksharyan, I think. The project name is E-Aksharyan. I did not put, they put. So what are the types of annotations we should have? The types of annotations we can have are not only a box and saying text. So typically in object detection problem people do, they draw a box and give text and that's the annotation. The annotation can be much more than that. The annotation can be a audio explaining it. For example, one word itself, one expert may speak 1 hour about that word. So I'm saying it's also possible, one word itself, they defend that author so many. So the explanations can be text as well. Not only text, I mean to say audio as well. The same pattern may have different interpretations by different authors. So the system should be able to capture all of those multiple annotations per pattern in a given text source. All of these things should be accomplishable. So here I'm showing an example of a palm script here. You see that? This is Telugu, old Telugu type of document here. I think this is an inscription. It's not a stone inscription, it is. I do have palm leaf images as well. You see that there is a lot of variation here. So how you process stone inscriptions is again a separate item itself. I will show some images where it's very hard to recognize stone inscriptions itself. So the text sources are, multiple text sources are there, either handwritten text or palm leaves or inscriptions or 3 prominent sources of text. Inscriptions, they have their own complexity, like the smudges on the wall and so on. And the patterns may bump into each other when they chisel it, right? So the pen for inscription is different. They have this metal and that's the pen there. So it has its own complexities there. One character bumps into another character and so on. No, I'm saying author 1, author 2, interpreters, commentators. For example, you have Ramayana copy, I have Ramayana copy. You interpreted one word in one way. I interpreted that word in a different way. So instead of keeping only one person's perspective, the annotation system should take both the perspective. So Ramashri madam thinks that it is so and so, Kalidas thinks that it is so and so. The user, it's up to user whom to believe this one. So there are a lot of document sources in every house as well, I would say. This is one source in my house, trunk box, lot of documents. My own grandmother wrote some things. So is there a way in which people bring out the dying knowledge in their houses, upload it to the system such that it becomes alive, is one problem. So not only palm leaves is okay, kings made it and then it's preserved. But what about non-palm leaf content as well? So it's handwritten content, it's wealth for that guy. So for that family it's wealth. Once it's lost, it's lost. So is there a way where this kind of sources also can be uploaded to a platform? So this is also another source where annotations are required. So the content can be out of print as well. It may not be printed. It may be printed content, but they are not printing anymore. So that also becomes a source of data here. So Indian Digital Library, this was some 4 years back number, possibly it's more now. It has 18 crore pages from 5 lakh books. So all of these are just photographed and kept there. So someone should go and do OCR on them, or advanced OCR on them. That's the opportunity area for us. So what have we done here is this. 3 years back, we created a platform. We had plans to enhance it to accommodate the features I was saying. So this was the 3-year back platform. So there is an interface. The input to the interface is language agnostic. That means the data can be from multiple languages. In the same document, multiple texts can be there from different languages. As you are seeing here, it has English, Kannada, Telugu, multiple characters are there. So is there a smart way where the system can be fed with annotations, which are rectangular boxes for now? I will show the other work we did on non-rectangular boxes I will show. So the input to the system is these boxes with annotations, and the output of the system is wherever they come, again in some other document, should be able to recognize it. So that's the challenge. So the other challenge is it should be real time. That means if the person who is sitting in front of the system feels that, hey, this is wrong, he should be able to mark it and say this is wrong. The system should go and correct immediately and then come to action. If the user feels that, draws a box and says, okay, this is new one that is missed out, the system should immediately learn the model and be able to detect it using very lightweight models and in real time. So that's the requirement, what we have tried to address. So glyph level models, we will have not one model, we will have several models, maybe hundreds of models, but very lightweight models. Can we pool the models, saying, for example, all the ka, kha, ga, gha, nya, let us say, that is kavargam, right? Pool the models for each of the characters and say that this is kavarga model. All the model pool of model pools, we call that a model pool. Pool means group of models. Pool of models is possible. That's the recursive definition we have provided there at that time. So can we have language model in the post-processing phase? So one of the things we saw in the literature is this. One limitation, I would say. When the character recognizer or pattern recognizer is recognizing a particular pattern, it is also having the language model inside it. For example, if it wants to recognize something as ka, to recognize the letter ka. So the language model is saying you should not recognize as ka, you should recognize as ga because the adjacent guy is so and so. So the object recognizer is burdened with the task of language, knowledge of the language. That is making the models inflexible. What I mean to say is, if it wants to say something as ka, let it say without knowing the language model, without having the language model in it. So if the recognizer is tightly coupled with the language model, the limitation, it will be highly limited in scope. You cannot expand it beyond, because you can only expand it for that language. So what we did was, we decoupled both the things. Let the recognition happen separately. Let it be right or wrong, let it recognize. Let the language model take those recognized patterns and then correct it later on. So the language models become plug and play there. The recognizer is independent. Language corrector is independent. So this is what we have taken the stance there. So one more thing is how to show the text, right? So there is something called reflowable text. So if you see Kindle device, some of you would have seen the Kindle device, or even our phone itself. When you are reading an article like this, or like this, when you enable that accelerometer, it restructures the text. Like this means the structure is reflowing in this way. When you put it like this, the structure so that's called reflowability of the text. So can we have a reflowability feature here is one more thing we have explored here. So that means, for example, this is Om Namas Tripura Sundariya Namaha. This comes, right? In Khargamala it comes. So if it is showing in horizontal, it is in this form. When you show in vertical, it can be split. And for each pattern, you can have separate annotation there. So these are all various possibilities with text sources. So the other type of text source, I showed you prescription. So this is one page summary of the discussions we did. So some of the other sources of text I did not tell. I'm showing it in this slide here. So the other sources of text include the wild text. This is called wild text. Not the text in the forest, but text in the natural scene is called wild text. So the wild text, what it corresponds to is the text that we see on the signboards and the shops and all is called wild text. So can we detect wild text is also a problem. There are a number of algorithms that detect wild text as well. So here text on the ambulance, text on the signboard. So where does this come into picture? Okay, these things, do they require some literary analysis? The answer is no. They have application in visual assistant systems. Let's say a vision impaired person is going out with some lens. So can it help? So Google is doing, but we are not doing simply because they are doing first. So basically, this is also an opportunity area where text detection has a lot of use cases here. Okay. No, that is, the algorithm doesn't know whether glass or not. The input to the algorithm is an image. That is an application, madam. Underlying algorithm is all same actually. So the underlying algorithm is the text sources are different, I'm saying. So even the Google Glass or lens technology also has to use in the underlying thing character recognition or pattern recognition methods. So here the sources are different, wild text. So multiple sources are there, at least 4 different sources are there. Prescriptions, old documents, palm leaves, then wild text, multiple sources are there. How do we recognize? So I'm just showing one demonstration. So I'm playing a pre-recorded video of this. So okay, we have put too fast, I think. Okay. So it has multiple languages. The user can log into the system. The user can select what document they want. So I will pause it here and then explain. So what's happening here is, this is a test document having mixed language content. Now, what's happening here is a particular pattern is selected and the label is drawn in real time here. So you see, model is being built in real time here. This is the thing. Okay, I will play it. Yeah, I will pause it when the time comes. Yeah. So when I'm clicking, it's going to the next slide. That how do I control it? I'm trying to see. Yeah. The crux of the invention is building models in real time. That's the new thing that we have. Different channels, yes. No, different sources. English, different languages. Domain also different. So in one of the words is aspirin. Another word is Telugu word, English word. Multiple things are there. So if you see here, I'm creating a modal pool for 3 types of patterns. One is Telugu word Kani, Kuda, and Hindi word Piked here. So that means there is a modal for the Hindi word here. If you see here, there is a modal for Hindi word here. So we drew a box here and said this should be called piked. I don't know the meaning of that word. So piked. So then creating a model for these 3 words and then seeing, okay, if it can detect it, not only in the document, but in other documents where the patterns are more or less similar. So you can create multiple models in real time and then select the models, what you want to pool them, give a name for them. Now a model pool is created. Select the model pool and perform auto annotate. So if you see here, wherever those words are coming, it has auto annotated. The idea is this. So here this included these words like Kannada ma is there, Telugu English word is there, and so on. So human has to validate. So human validated. So human corrects those annotations. If something is wrong, human says wrong, and it will correct, and then it will change it. So let's look at this. Whatever missed ones, you can add. Whatever wrong ones, you can click and delete them. So you perform auto annotate, it will perform for the missed out ones or the wrongly predicted ones. So this we have set as very super fast demo we have put. We should have reduced the speed anyway. So basically, what this platform does is, it takes annotation as a service. What I mean to say is, like let us say if I say that I'm going to create yet another OCR engine, nobody likes that idea. Why? Government already burnt hundreds of crores in OCR building for past 20, 30 years. So now, if I have a model that integrates existing engines seamlessly, then it is most desirable. So what I'm showing here is, so I will send one, I means we, the program. I will send one document to a Tesseract Malayalam OCR engine. I have no clue about Malayalam. So the Tesseract Malayalam engine will draw these boxes and give annotation saying this is this word, this is this word, this is this word. So this system treats it as if some human-driven, written by hand, trains the models corresponding to the Malayalam engine's output and then performs on new documents as if it learned that. So that's the thing, what it is. I will show some accuracies and all what we got. So it connects to the Malayalam server. Malayalam server means Malayalam OCR engine server. Got the annotations as if done by a human. So annotation as a service is the one. So now, given, so what is happening? I just forgot. Okay. So Malayalam, you can send the document, get it, and then once you get the annotations, you perform annotation on the new document. When the new document comes, you apply these learned models. Whatever are wrong predictions, go there, delete them, or add new ones. It will update the models. That's the fundamental idea. On the right side, what you are seeing are all the models what are created. So these are not just character level models, these are word level models. Because when Dr. Wright wrote aspirin, he just wrote aspirin like this. One should have a model for that. That's a cumbersome one, right? But now things are changing. So you don't need to have a separate model for each word. I will show some examples here. No, it's not possible, madam, because you cannot, so when people write, they use cursive writing to write. You cannot say this is my character. One character bumps into another character. So you should have some different way of marking, okay, this is my character. It may be bumping into the other character's zone. So that is one thing here. Yeah. Speech will convert to text, so that is different. Yeah. Okay. Pronunciation to another pronunciation, difference will be there. No, techniques will be different, madam, because in speech what you are dealing with is a time series data. So here also it is Yeah, yes, it is a signal. First point, it's a signal type of data. It's a 2D signal because it's a image, it's a 2D signal. So in speech also it's a signal. You do have a signal data, but this signal, the nature is different. So you have these boundaries, boxes kind of information. So we created a lot of synthetic corpus on existing different data that included 351,000 images from English, Telugu, Kannada, Devanagari. 4 different languages we have selected, English, Telugu, and then 3 types of patterns, letters, words, and digits. So on 351,000 systems when we evaluated, we got some decent accuracies there. So for words, it was about some 96%. For letters, it was, in some cases, it's 100%. On that data set, I'm saying, the disclaimer is, on that data set, it worked well, but more ones, we don't know. So at that time, we tested on 36 classes of letters, Kannada 53 classes. So we got some decent numbers, 99, 89, and all. We got some decent accuracies on that. So for digits also, it was good. Digits, it's fine, because people typically write digits separately. They don't write cursive for the digits. So one more interesting thing here is sub-patterns. If you see here, if you look at the OCR engine's output, so if I touch it, it changes. So So you see that tesseract is shown here, Siriakshara is shown here. 2 different paradigms I'm showing here. I'm trying to detect this circle here. Circle is Bindu, right? So Bindu I'm trying to detect here. Purnam, right? Purnam or Bindu. So Purnam I'm trying to detect here. This Purnam can come in different forms. For example, Ra is there. In Ra also Purnam is there. Re is there, Purnam is there. Can I extract the Purnam out separately, independent of the connections what it has? That's the problem. So that's the requirement, I would say. So we were able to address that requirement here using the CNNs and all. So tesseract was able to detect several wrong ones. You see that here? It's detecting do, T, Ka, all of these wrong ones I have put. So here, this algorithm is able to extract these patterns properly. For example, Ga, we are trying to extract the pattern Ga here, Ga. So Ga comes in Gu also. Ga, you put one extra thing, it becomes Gu. So it's able to detect the sub-patterns as well. So here this is La. La comes with Lu, Li, Lo, all of these things. The same pattern is attached with extra things. It's able to extract the sub-patterns in that. So basically what we are doing there is very lightweight models which make use of the nature of the document. So the consistency of the pattern will be there in the handwritten texts. Typically one author writes means for several hundred pages, consistency more or less he will maintain. So can we make use of that information? So we came up with one mathematical model called pattern and anti-pattern model and try to convolve the images with patterns and subtract with the anti-patterns, and then so did a lot of modifications on that. So this is one area where a lot of collaboration is also possible. So this is one area where a lot of experts can give their free time for annotations, provided an annotation is platform available to everybody. So this is one good opportunity area for collaborations. No, we are waiting for that SHRI funding because somebody should be there to make it proper. So these web services are running in our local laptops kind of things. But models are very lightweight. So this is one thing I thought of presenting. Now other source of knowledge, I will shift to other source of knowledge now. So this is about inscriptions. So in Indian knowledge systems, there is a project module that was given to me by Professor Surya Narayana Ganti of IIT Indore on if an enthusiast goes to an archaeological site with their phone, point to an inscription, get the data about that particular spot and show it on the phone. That is the problem statement. So I go to a temple, mobile phones are not allowed. So it's not applicable for temples possibly. But if I go to an archaeological site, I point to some interesting regions in the archaeological site, and I should be able to get information about that particular spot, whatever be it. Some object may be there, some sculpture may be there, and show it on the phone saying, this is the speciality of this, what you are seeing. So this is the problem statement. Now, yeah, I will show those complications now. I have kept some slides for those complications. Yeah. Yeah. I will show it right now. I will show it. You are right, madam. So initial idea was, can we do OCR on inscriptions? So my gut feeling was saying not possible and all. And then we verified it, that it is really not possible. I will show some examples here. And then we we changed the problem statement to something even more interesting. I will show the patent on that now. So this is a inscription. Yeah, this is an inscription, not palm leaf, some inscription. Inscription. Somebody with chisel, they did it. I think, yeah, there is some hole there. It may be copper plate, but it's looking black in color. Jelly, yeah. So the problem here is, this kind of data is clean data. So let us accept that this is cleaner data. Now we can see some characters in that neatly. Now if we do OCR, some engines can do up to some extent. I think this is Bengali or something. Bengali, yeah, I will show some, I think it is Bengali. So up to some extent these engines can recognize. That much is there. So now let's look at some more complication here. Yeah, this is Bengali. So this is Bengali Tesseract. When I ran, I got this Bengali output here. Assamese, huh? I think Assamese. Yeah. Assamese. This is Assamese inscription, yes. And this is plate. Sir, what you said is correct. It's written plate here. That's a plate. Yeah, it's a plate. So this data is coming from Epigraphica Indica. There is a database of Epigraphica Indica. It's maintained in NIT Trichy area. One NGO is maintaining it. So we are making an MOU for they have some 4,000 images on this type of data. So, but now we use their public data and then prepared on that. So, yeah, this is a Gujarati inscription. Can you see that Gujarati inscription? This is a little bit complicated, isn't it? So cluttering is more. The words are too proximal to each other. But still, to some extent, these engines are able to recognize. That much is there. This is unknown language. We are getting into more complicated scenarios now. This is some language the OCR engine was not able to recognize. Can anyone in the audience know it? I also don't know. So some Hindi OCR tried to process and then got some words were similar found in that. So the inscriptions have a lot of problem. Do we agree with that? So inscriptions, timing them and all is complicated. So this is a Devanagari inscription. Some of the patterns are old Devanagari. So Devanagari itself has several versions. So this is one of those versions when it was etched. So this is a plate. This is also a plate. Some of these are plates. This was also a plate. This is Kakapura, something is written there. This is Devanagari only, this is also. So you see here the OCRable region is very less. So if you see the green region out of the black region, the green region is very small, isn't it? Only that much we know about this script. So the problem requires a different way of handling. So I will show the different way of handling. So this is a very hard to do thing. So you find inscriptions of this format. It's a very difficult case, right? I don't know what that letter is. It's in Madhura, Jaina inscription, it was written there. Can we do OCR on that? It's not possible to do, right? What can we do in a smarter way there? We'll see. If we can know what is that object and retrieve information from the database of human annotations that is smarter way we can do. That is doable by us. So for example, if I take my phone, point it to some object, click it, now from the database of several thousands of images, if I can figure out that, okay, this image is about this, the query image is index image 10 in my database. For image 10, this is the explanation. I retrieve that explanation. That is easier to do. But what is difficult to do is, for the entire archaeological sites in whole of the country, or possibly the world, or for all the temples as well, if in some parts they allow mobile phone, let us say, you will have several lakhs of images. Because in one site itself, you will have several thousands of images. Because I'm not talking about summarized description of the entire site. If you go to any temple, you find something called Kshetra Puranam. Kshetra Puranam is summary. It's not talking about that particular site, that particular spot, what is that information. We want that information. On that particular spot, what do you want? So spot specific information is a huge task, because the query image has to be searched in the database of several thousands or even lakhs of images in real time, because somebody is waiting for the response. You can't just rotate and say, after 2 days, if you come, that guy would have left. So, so can we retrieve the information in real time? So the answer to that is, we need some engineering interventions there. One of the interventions is, some of these are very common sense interventions. One of the interventions we can have is, what is my GPS coordinate? That itself will filter out the number of images. Once I know that my GPS coordinate is x comma y, latitude comma longitude, I don't need to bother about the GPS coordinates which are far away. I know that this temple or archaeological site has this boundary, so I restrict my search to that boundary. Even in that archaeological site, you still will have several thousands of images. So you still need to reduce to a 1 or 2 images. How do you do that? So how to do that is via indoor positioning. So indoor positioning means, within one site, without using the latitude, longitude, can I know my position? It's called indoor positioning. There are some existing methods for indoor positioning. One is based on beacons. You keep radio frequency based beacons. But that is only suitable for malls kind of a situation, for shopping malls type of environment. That intervention is suitable. So you are near a witch shop, or you near the exit or not. But that is not the case here. You have a, who will maintain those beacons will become a problem. So for that, we have come up with one idea called visual indoor positioning algorithm. Visual indoor positioning algorithm, I called it VisPin technology. So we patented it, filed for a patent on that. So the idea is this. If I know specific signature pattern on what I am seeing, I means that phone, or I means that algorithm, what it is seeing, that unique pattern can be searched in my database of several patterns. That's the idea. So once I know that this is my temple, I have 10,000 images of the temple. Once I know that, I'm looking at this specific indoor position, I reduce my search space to just 1 or 2 images. Once I know 1 or 2 images, again I search in those images for those key points. I will show those key point images now. Okay? So this is a very hard thing where OCR is not suitable. What is suitable is, can we leave it? The answer is no, we cannot just leave it like that. So let human do the explanation part of it. Let human record the explanation saying, in this spot, this is the information. Let the human do that. And what the algorithm can do, retrieve that information in a smart way and present it to the end user. That's what we can do. So I will show a couple of other examples. You see, broken images. So the inscriptions can be broken as well. Here, these are broken. So those are not written clearly. Yeah. To identify the location. I will show it right now. I will show right. The algorithm I will show. I am sure I'm presenting the problem challenge I am presenting. What attempt we did, I will show now. So you see, it can be broken like this. OCR is very hard to do. What OCR can we do in this? There is an elephant there. Somebody drew an elephant and then he wrote something there. He or she wrote something there. Mostly he. Yeah. Yeah, it's broken script. So can we have some explanation made by the human and be able to retrieve it in a smart way is the motivation I'm trying to drive here. So it can be of various complexities. This is a very complex inscription. It can be in some very unknown language. See that this inscription, really difficult to make, right? This is almost like, right? There are inscriptions of this sort, different arts, different patterns here. So this is looking like Chinese. Don't know. Brahmi, sir? Okay. This is also? This is? Variations of Brahmi. What? This one, sir? Brahmi. So very low resolution as well. That means the inscription damaged, and this is some word art. Do you know what is this, sir? Like some looking like Arabic. This one? Brahmi. Brahmi. So they have this word art here. The inscriptions are in this format here. This one? Brahmi. This one? Some variation of Brahmi. What about this? Yeah. So given this information, what to do? I am presenting the idea here now. So what we did, I am presenting here. So the idea what we worked is this. Detect key points in the images and then store the key point and their descriptions in the database. Create a KD tree, k-dimensional tree. Given the query key point, search for the matching key point in the database and retrieve the corresponding information. That is the fundamental idea. Before retrieving the matching information, filter out the data. When you have several thousands of images, filter based on the GPS coordinates once, the zone of the area. Next, filter based on the visual indoor coordinates of it, and then do this key point matching on those one or two images. Once you find those one or two images, do specific matching on that. So we came up with one idea called WizPin technology. The idea is this. Once we have a specific pattern kept in some place in the entire wall, need not be attached to every place, based on where it appears in the phone. Like if we take the phone, like I attach this type of a sticker. If the sticker is coming to the right side corner of my phone, I know that I'm looking here. If the sticker is coming on the left top, I know that I'm looking like this. I'm looking in this angle. So I know the, yes madam, I know the distance at which my phone is there and the orientation at which my phone is seeing what it is seeing. Based on that, I create annotations for various spots in a archaeological site. So given the query pattern corresponding to unknown position of the circle, this is called WizPin, I'm calling it WizPin, and its position and orientation in the phone, I can uniquely retrieve what is the closest matching known database entry from the database and show that, hey, what you are seeing is this. So that's the idea here. So the key points look like this. For example, if you take one inscription, try to detect fast key point. There are something called fast and ORB key points are there. So if we look at feature activated segment test, fast corresponds to feature activated segment test and ORB corresponds to, I forgot the name. So the number of key points is too many here. So each green one you see is a key point there. So it has about 10,000 key points in one image itself. That means if I go for searching for these 10,000 key points, the time complexity will be as much as the number of key points I'm having in the database. So can I have a smart way to reduce the number of key points per image? That means when I take a photograph of a inscription based place, I don't want too many points in that. I don't want too many corners in that. I just want one or two semantically meaningful corners in that. So that's called semantic key points algorithm. We have created that algorithm. So it just returns some 5 or 6 semantic key points per view. So if the view is a plain wall, no key points there. If the view has peculiar pattern, it will have unique key points there. So based on the query images, what key points are there? Based on the database images, what key points are there? How many of them are matching? I can retrieve with a confidence score saying this is what you are looking at. And that confidence score will be enhanced by the vispin what I showed, the circle and ball kind of a pattern there. So this is the algorithm. What we did was we tested it on, because at that time we did not have this inscriptions, real photographs of inscriptions. So what we did was we should not stop the work. Either wait for the data and don't do the work, or do the work in some form or other, right? So we took the second approach. So we went to IIT campus, multiple places, clicked photographs. We went to National Sanskrit University. Kunal was there, Jayasimha was there. They clicked hundreds of photographs of this. And they also wrote code, contributed code to that. They did internship with me. So clicked hundreds of photographs. Given a query image, it matches the database of images, and it was matching quite well here. So we did on the proxy data. So it was also provided as a app, basically. So the IKS fund sanctioning professor asked, has a vision to have an app. So we made an app for that. So the app had a Flutter interface. It can run on the Chrome browser, or it can run on the mobile phone. And then it connects to the Node.js server. That connects to the Python server, and everything in Docker containers, basically. So basically, it extracts data. Given a query pattern, it extracts the known patterns there. If it is already known information, it will retrieve. New information also you can add. Means like you take the phone in administrator mode, you click the photograph, record your voice, or just type something, it will add. Right now we have put only typing. So you can type in the text box, add a pattern. For the new one, you go there and click somewhere nearby. It need not be exact, just somewhere. It will be able to retrieve uniquely, saying that is the closest match. So that's the idea here. So we filed for a patent here. So as everything was completely implemented, we filed for a complete patent on this. So this is, I will stop here. So the take-home message is this. There is an opportunity for NSU to contribute in the form of knowledge or in the form of codes for two types of sources. One is the text sources coming out of this photographed palm leaves or inscriptions. Okay, palm leaves, or the second source is inscriptions. There is an opportunity for IIT Tirupati side to contribute with CDAC officers on these type of projects. So that's the good win-win situations we have here. Thank you very much. Questions I will. Yeah. Yes. Yeah. Yeah. So heat map generation, it's a pluggable item. Actually, you have this thing called attention-based heat map generator. Explainable AI comes up with its own modular feature where you input an image and you provide the classification labels for it. So what class is it classifying due to what features? Here features correspond to the pixel coordinates. So heat maps can be generated for this also. So heat map is an additional feature you can have. So based on the heat map also you can select what points are important. So here I'm not select, I'm using, yeah, sorry. Here we have not used explainable AI modules here. So explainable AI is a addendum. For example, you take any algorithm you take, you can add explainability to it. So here we have not yet added explainability. That's because we were using something called shifted descriptors, scale invariant feature transformers, which were known in the image processing era. So we just use those shifted descriptors. Surf descriptors are also possible. And later we created something called semantic key points. That is based on the user's input saying, this user is saying these points are important. Rather than heat map saying what points are important, user is marking. So can we recognize them? So like that we have formulated this problem. So thanks for the question. Any other questions also, we'll be happy to answer.
Sir, thank you so much for the insightful talk in this workshop. And to summarize the concepts, actually what sir has covered is wonderful research towards NLP. And sir, it's insightful. The platform is very good, the Sri Aksharam platform, right? Sri Akshara platform where, so Sri Akshara platform where all Indian heritage, cultural heritage documents has been consolidated, collected, and platform has been established for collecting, and as well as annotating with the different modalities, with audio also, text also. That is a wonderful research, sir, which will help for the research community as such. And the next one is what I have seen is that annotation tool is a multimodal and it is a multilingual annotation also as in, and the service is being available. I think if this annotation service can be provided for the public, it will be very grateful. I think once it is being tested, you can able to deploy and give it as a service for the public too. And sir has gone to, the research has gone into the depth level, like a character and a word level research, and further can be taken forward for a phrase and sentence also. Maybe, I'm just, my words, I just want to put it up over there. And with respect to inscriptions and the whatever the inscriptions has been captured, okay, with IIT, with the help of IIT Indore, and the research has been carried forward. It is really wonderful research over there, and especially the patents information going to the Indore positional system, as well as the query optimization techniques and algorithms has been built up for the information retrieval. That is one of the wonderful research work. Really, it's very grateful to you to have today's talk on this platform, sir. Thank you so much.